Hello everyone. Today in this video, we'll be discussing about one of the array problems from Leetcode. The difficulty level of this problem is easy and the title of the problem is +1. So according to the problem over here, it states that we have been given an integer array which contains digit of a large integer and we have to add 1 to the large integer and find the resultant array. So let's understand this with some example. Let's say we have a number 123 and the resultant array for this is 1 comma 2 comma 3. So this 1 comma 2 comma 3 would be given as an input. Now it expects us to return 1 comma 2 comma 4, which is an equivalent of 124, which means 123 plus 1, 124. So this is what it expects us to return. So let's first understand the problem constraints as well. So problem constraint over here that are given to us states that the number of digits may vary from 1 to 100. That means the large integer, that is the integer that we are discussing over here, like for example 123 or any number that it would be stating to us, can have 100 digits. That means there is no integer data type available to us which can hold an integer as large as this one. So that means you cannot go ahead and convert this array to an integer and solve this problem. So how do you approach to solve this problem? So to come up with our approach, let's try to debug this problem with some different examples and let's see how to proceed with the actual algorithm. Let's take another example. Let's say for example you have been given a number 2 comma 3 comma 4 comma 5 comma 6 comma 7. So this is an input array that you have been given. This is equivalent to 2 3 4 5 6 7, that is 234,567. This was your input number. So the resultant array would be 2 comma 3 4 5 6 and 8. So this is the resultant array. Now let's understand another example. 1 comma 2 comma 9. So this is n number, that is 129. So what should be your output? That is 1 comma 3 comma 0, that is 130. Let's say you have an number that you have been given as 999. So what should be your output? Your output should be 1 0 0 0. That means if you closely observe in the above examples, the length of the array did not change, but in this example the length of the array has changed. So you have to take care of this example as well. So how do you approach this problem? So if you closely observe that if we start from the last and we keep adding 1 to the digits, and if the digit is not 9, we just add 1 to the digit and that's it. We don't have to do anything else. But if the digit is 9, then we have to convert this to a 0 and the next element has to go to 1 plus. Now for example, let's take this case 1 9 9. To this example, if you see, this 9 should be converted to a 0, then again this 9 should be converted to a 0, and then the first element, that is not equal to 9, should be incremented and your solution is done. We don't care even if we have, let's say, 10 digits over here, or let's say n number of digits over here. So we don't care about them because they would remain as it is. So this is what the algorithm states. So let's write a pseudocode for this. So I will say that I have a loop that starts from n minus 1 for I. This loop is running for I variable and starts from n minus 1. Now why n minus 1? Because we would be traversing from the right side of the array and we would coming to the left side. So we would start from the least significant bit and we would come up to the most significant bit. So we would be traversing in that direction. So we would start from I is equal to n minus 1 and we would go up to I is equal to 0, both inclusive. So we would also iterate on 0, we would also iterate on n minus 1, so both inclusive. So this is the for loop that we are talking. Now if digit of I is less than 9, then what we have to do, if you know that any digit that is less than 9, we just add 1. So let's say in 7 this was less than 9, we just added 1. Over here it was less than 9, this first digit we added 1 and that's it. So we would add digit of I plus plus and then return digits. So this array would be returned. But what happens if the digit is not less than 9? That means digit would be 9 because there is no other value possible for a digit. Because if you see the constraint as well, or if you think it through, no digit can be greater than 9 because any digit of a number is from 0 to 9. So that means this 9, if that is 9, we would have to convert this to a 0. So that means digit of I double equal is equal to 0. So this is my for loop, and let's say we run from 9, then this 9, and we come up to this 1, we incremented it to plus 1, that is 2, and we returned. What happens if we have all 9s? We would come to this point, we would convert this to 0 as well, and still we would not encounter this condition anytime. So that means this for loop has not returned anything for now. So this is the only edge case that would be left for us. So what we have to do is we just have to append a 1 and then all the digits that are there in this. Practically all these digits would be 0 for our scenario because we have converted them to 0. So we would append all the digits from this digits array and this would be our return. Now if you closely observe, what is the time complexity of this problem? So we have just one loop that runs from the last index to 0th index, just one loop. So that means the time complexity of the problem is big O n. So this is the time complexity of the problem. And what is the space complexity? Space complexity is big O of 1 because we have not created any new array. We have not created any new array. So now let's see how the code would look like for this example. So the resultant code for this problem is this. So over here I have a variable n which is equal to the length of the digits. I start my I from n minus 1 and I go up to I equal to 1. I keep decrementing I every step. Now I say if digits of I is less than 9, I increment the digits and I exit from the loop and exit from the function. I just return the digits because if you remember, it's the breaking condition where I have to go out and I didn't find a 9. I just incremented a number and I don't care about anything left in the array now. But if we don't encounter this problem, that means this condition, that means we have encountered digit of I as 9. That means that has to be converted to a 0. So we have converted that to a 0 and then we have come out of this loop. So that means we have a condition where all the digits that we have encountered are 9. That means every time we have gone to this part. We have never reached this point. That means now we just have to append a 1 and then add all the digits and keep it as it is and return the digits. So this is the code that is for the algorithm that we just discussed. So that's it for this video today, and in case you liked the video and it was helpful for you, please do not forget to like, share and subscribe to our YouTube channel. Also comment down below in case you want any particular question from Leetcode or Geeks for Geeks to be solved by us on Golang, or any other topics that you want us to cover for you guys using Golang. So go ahead and comment down below as much as you want, any topic on Golang, using Golang. We appreciate you guys to do that.